So for today's lesson, we are going to continue with our differentiation. And in the previous video, we covered all the basic rules for differentiation already. So for today's onwards, we are going to actually discuss how to use all the technique of differentiation to apply it in application questions. All right, okay. So first for today, we are going to understand the idea of gradient of a curve and also use the notation f prime x, f prime x, and so on. All right, then to apply differentiation to the gradient, tangents, and normals. All right, so all these are something that we need to learn for today for this video. Okay, so let's start with the concept first. So now, well, when we talk about the gradient of the tangent of a curve, generally you need to apply differentiation. Okay, also when they're talking about the gradient of normal of any curve, you also need to apply differentiation. All right. Okay. So first, we need to know what is the meaning for tangent and also the normal. Okay. So let's have a look for a simple example. Let's say I'm having a curve. I simply draw any curve on the axis. Let's say this is my curve. All right. Okay. So for every curve or any curve, okay, on any line and on any point on the curve, let's say this is x1, there will be y that touch and pass through the point and also the curve and the point x equal x1. Usually the x1 will be given in the question usually. All right. Okay, then you'll see that actually I can draw a line that touch the point and the curve once. Okay, and this particular line we will call it as tangent. Okay. All right. So that means on any single or any graph, all right, so you actually can see there are a lot of different tangents. So like this is the first tangent that I have. Okay, the tangent that I have. Then maybe when I'm having x2 here, so I will actually got another tangent. So you'll see that these two tangents will have different equations. All right, the gradient is different, then the equation is also different. It based on where is your x. Okay, then at the same time, if let's say you are having another line that pass through the x1 through the particular point and it is 90 degrees to the tangent, so this particular line we are calling it as normal. So when they are talking about the tangent of a curve or normal of a curve, these are the mean. Okay, so same thing happen, you have having a lot of different normal. So as an example, if I say this x2, you're having the tangent here, then the normal is something like a line that pass through x2 and it is 90 degrees to the tangent. So we call this as normal of the curve at x2. Right? Okay, so for this whole part, we are going to learn how to form the equation of tangent and how to form the equation of normal. And of course, there are some concepts they want you to apply to related to this one to answer the question. Okay, so we'll start. Okay, so what's tangent? So the tangent to a curve at a given point is a straight line which touches the curve at that point, and then the normal is actually the line perpendicular to the tangent at that point. All right. Okay, because these two lines are perpendicular to each other, therefore you should know that the gradient of tangent multiplied with gradient of normal is equals to -1. So this concept you learned it in coordinate geometry before. So I hope that you still remember about this. All right, so this is one of the important concept or maybe important formula that you need to remember for this part. Okay, then to get the gradient of tangent of or gradient of tangent, yeah. So to get the gradient of tangent of any curve at any point, you need to remember this one. The gradient of tangent is actually dy over dx. All right, so the gradient of tangent is dy over dx, and you need to substitute the value of x1 into it to get the gradient. All right, so once you substitute the value of x1, again, usually x1 will be given by the question. Substitute the value in already, you'll get a gradient of tangent. Then after that, by using this gradient of tangent, you can form equation of tangent. which is again the concept that you learned in chapter 3 before, y minus y1 equals to mx minus x1. Alright, then to get the equation of normal, then you use y minus y1 equals to gradient of normal x minus x1. So of course, before you want to get the gradient of normal, you use the equation just now, the gradient of tangent multiply with gradient of normal, and it is equals to, it is equals to -1. Alright, so after you apply this, get the answer for gradient of normal, then only you put it into the equation of normal to get the answer. Alright, so generally this is some simple basic concept on how to form the normal and tangent equation. Alright, okay, so maybe you can have a look at the example and see usually how they are going to ask us this application question. Okay, so example 5 is a basic one. Right, so first they actually want you to find the equation of tangent and also equation of normal to this line at this point. So you see that they will definitely give you the value of x. Okay, so how to form the equation of tangent and normal? So we can start now. Alright, so when you see the keyword equation of tangent or equation of normal, generally what you need to do is first you need to do the differentiation. Alright, so I'm having this curve, therefore I need to do the differentiation. That means I need to find out dy dx, which is 3x squared minus 4x. Alright, and then when x equals to 2, you need to find a few things. You need to find the y also. So how to find the y? Substitute the 2 into the original equation. So you have 2 power 3 minus 2, 2 squared plus 4. And therefore you will get the value of y equals to 4. Alright, so you get a point already. Then now you need to get the gradient of tangent. So I need to find out the dy dx. Just now you already know that dy dx is 3x squared minus 4x. So now you substitute the 2 into your dy dx. Right, so when you substitute the gradient 2 into the dy dx, you'll get a 4 as well. Alright, so your dy dx is equals to 4. So please take note that this is actually your gradient of tangent. Alright, so the gradient of tangent should be a value. Okay, you shouldn't substitute x into the equation of tangent. You should substitute a value. Alright, then now let's continue. So once you have the point, once you have gradient of tangent, then you can start forming the equation of tangent already. So how to get the equation of tangent? Right, so equation of tangent is y minus y1. So what is the y1? You already get the value just now, which is a 4, equals to 4x minus x1. So x1 is the value that I give you in the question, so it is 2 here. So if you try to simplify it, you will get y equals to 4x minus 4. Alright, so this is the equation of tangent. Then now, how about we try to get the equation of normal? So the equation of normal, you need to get gradient of normal first. Alright, so what is the gradient of normal? It is -1 divided by the gradient of tangent. So it is -1/4. Alright, then now I want to form the equation of normal. Okay, so the equation of normal will be y minus y1. Okay, the y1 is still the 4. We are using the same point. Okay, equals to -1 for x minus x1. So again, the x1 is still the 2. We are still using the same point to form the equation of normal. Alright, so once you simplify it, you should be able to get -1/4x plus 9/2. Alright, so this is how we form the equation of tangent and normal. Alright, so just make sure that you remember what do you need to form the equation of tangent and normal. Of course, you need the gradient of tangent, the gradient of normal. Therefore, you need to do differentiation. Right? Then, of course, you need the point also to form the equation. So the point, you can get it easily from the equation itself. Alright. Okay, so this question, what I can say is like a straightforward question. That means it's very straightforward. They just tell you to ask. They just ask you to find out the normal and also the tangent equation. Alright, okay, so maybe now we can proceed further to try a few more examples, which is not so straightforward. Huh? Okay, so again, for all the examples here, if you can try to pause this video first, attempt the example 6 and 7 before you come back and look for the answer. Alright, unless you really don't understand the concept here, then you can go through with the example and solution here. Then after that, you try a few more partial questions on your own. Yeah? Alright, so now let's have a look for example 6. Right, so for this example 6, okay, so they give you a curve with this equation, and then they say given that the gradient of the curve is -3. So when you see the word gradient of the curve next time, please always try to link it with dy dx. Right, so gradient of the curve, the symbol is dy dx, is equals to -3. For this case, for this question, when x equals to 2, find the value of the constant k. Okay, so again, in this question, the information given is something about dy dx. Therefore, if you can, try to get the dy dx first. So k over x, you can write become kx power -1. So first I want to find the dy dx first. K is a constant, you just copy. Power -1, you put in front. And then x, you just copy. Power -1 become -2. Generally, you are having -k over x squared for the differentiation. Okay, then now we come back to the information given in the question. So it tells you that dy dx is -3 when x equals 2. So I will let the dy dx equals to -3 when x is 2. So that means the 2 x here you need to substitute with value 2. Alright, so very easily you can get the answer of k, which is 12. Alright, so this question, they are still testing you about the understanding on normal, on tangent of the curve. Alright, but they actually focus more on the gradient of the curve. So gradient of the curve means the gradient of tangent means dy dx. Alright. Okay, so if no problem, then again, for the next example. Yeah, so this question I will strongly encourage you to try on your own first before you check for the answer. Again, please pause this video anytime and try it out first before you check with the solution. Yeah, if not, then you are not learning anything. You have to try on your own first. Right. Okay, so let's start. Okay, I'm having this equation. Okay, so they tell you the normal to the curve at this point meets the x-axis and y-axis at P and Q. Find the length of PQ correct to 3 significant figures. Alright, so maybe before I start anything, the question looks very long. Means a lot of things that you need to do. Okay, so maybe I will start from the basic first. They are talking about the normal of the curve. Right, so maybe I need to form the normal first of the curve first. Then only I can continue further. Alright, so again, to get the equation of normal, I need to do the differentiation first. So I rewrite my equation become 4x power -half. Alright, so first step, I need to find out the dy dx, which is equals to 4. You just copy, and then x you put it in front, x you just copy, power -1 become -3 over 2. So if you simplify everything, you will have -2, and then x power -3 over 2. Alright, then after that, since it is at the point of 4, 2, so that means this is your x, and 2 is your y. Right, so I will substitute the x by 4 with 4, and then I try to press the calculator if you want, and try to get the value for this. So you'll see that this is -1 over 4. Alright, so again, just to remind you all, what is the meaning of this -1 over 4 here, dy dx? So what is dy dx? Is the gradient of tangent. Alright, okay, then now, we are having the gradient of tangent here, but this question talking about the normal. Therefore, I can use the concept and try to find out the gradient of normal. Alright, so gradient of normal means it is equals to 4. So that 4 times negative 1 over 4, you get negative 1. Alright, then I can form the equation of normal. Okay, so how can I form the equation of normal? So y minus y1, which is the 2 given in the question, okay, equals to gradient x minus x1. Also given in the question, the x1 value is 4. Okay, then if you simplify your equation of normal, you will get y equals to 4x minus 14. Okay, so we are done for this part, the normal to the curve. So this is the equation of the normal. And then they say this equation, this line, meets the x-axis at P. So when you talk about meet the x-axis at P, means that y equals to 0. You let y equals to 0, right? Okay, when they say meet the y-axis at Q, so meet the y-axis means one y-intercept. That means you let x equals to 0. Okay, so you can let y equals to 0 to get the value of x. And then you let x equals to 0 to get the value of y. So that will be your P and Q. Okay, so this is a normal equation. So I will start now. You let y equals to 0. What is the value of x that you get? The value of x that you get, it will be 7 over 2. So which means this is actually your P. So your P is 7 over 2 and also 0. Alright, then when you let x equals to 0, what happened to your y? Your y is negative 14. So this also means that Q is 0 and negative 14. Alright, okay, so once you get the coordinate for P and KD, what they want you to find. So okay, you continue further. They want you to find the length of PQ correct to 3 significant figures. So how to get the length of PQ? You learned it before also, right? So to get the length of PQ, you use the coordinate geometry concept. Okay, so 0 minus 7 over 2 square, x1 minus x2 square plus y1 minus y2 square. As you take the square root, eventually you will get the answer 14.4 unit. So please keep the answer in 3 significant figures as mentioned in the question. So this will be your 14.4. Alright, okay, so these are a few examples that to show you how we actually use the differentiation to relate to the gradient of tangent, gradient of normal. Alright, so if you want to getting more familiar with all this kind of question, please have a look and try the partial question. Then you will learn more from that. Right?